Have you ever wondered when in the real world we would use exponents and powers? Well, you're right if you said they're used to represent very large and very small numbers. But where do we come across such numbers? If we were to study any branch of science, be it physics, chemistry, or biology, we will come across a lot of such numbers. Like the mass of the sun, the diameter of a pollen grain, the number of atoms in a human body, the thickness of a sheet of paper, the size of a virus, and the age of the earth. As you can see, there are some large numbers and some very small numbers. But what's common about them is that they will be extremely difficult to read if we were to write them like this. Take the mass of the sun, for example. It has so many zeros that it's difficult to read even if we put commas everywhere. What do you think will solve our problem? You guessed it right, exponents. Now, we already know how to express large numbers using exponents in standard form. The mass of the sun becomes 1.98 into 10 raised to 30 kilograms. This standard form is also called the scientific notation and is used so that it's easier to both compare and use such numbers in computations. But wait, what about the small numbers like the size of a virus and the diameter of a pollen grain? How do we express those in standard form? A number in scientific notation consists of two parts. The first part is a number from 1 to 10 and the other is the exponent of 10. In the case of very small numbers, the exponent of 10 is a negative number. Let's take an example. Bumblebee bat, the smallest species of bat and the world's smallest mammal, are usually 0.029 meters long. How do we express their length using scientific notation? The first step is to move the decimal point to the right to create a number from 1 to 10. Here, we can make the number 2.9 by moving the decimal by 2 places. The second step is to determine the exponent of 10. Note that 0.029 can be expressed as 2.9 divided by 100 or 2.9 divided by 10 raised to 2. And using the exponents law, this can be written as 2.9 multiplied by 10 raised to negative 2, which is the scientific or the standard form of the number 0.029. Notice that the absolute value of the exponent is the same as the number of places we move the decimal to get 2.9. And of course the exponent is negative. Let's take another example. The size of a virus is 0.0000008 inches. How do we write this using scientific notation? The first step is to move the decimal point to get the number 8. Now that we have moved the decimal 7 places to the right, the exponent will be negative 7. So, the size of a virus in scientific notation will be 8 multiplied by 10 raised to negative 7 inches. Just to be sure, let's check if 8 multiplied by 10 raised to negative 7 is the same as that. To do that, we will express 8 into 10 raised to negative 7 as 8 over 10 raised to 7 or 8 over 1 crore. This is what we started with, so our scientific notation was correct.